Well, let me start with a perhaps provocative one for Jeff. You mentioned at the end that basically both major lines of implementation have ABI support already following the new ABI. And you showed that there's very little performance impact to no performance impact, right, of doing it. So what's the value of still keeping the old ABIs? How can we convince them to just drop the old ABIs and use the new one?
Well, so the reason that vendors keep ABIs is because they have ISV customers that ship binaries, right? I used to work at Intel, and when, things with Intel MPI were, Intel wanted to be able to ship a new version of Intel MPI with new hardware support, and still run it with an ISV binary that might be 5 years old, right? Because, if, for example, if you do engineering simulation in a regulated environment, such as aerospace, automotive, of course, it's the same in finance and healthcare for other reasons. Changing binaries is not something that you do lightly. In fact, I know in healthcare, you actually qualify your medical equipment, including the Linux minor version release that you install on that equipment, right? So long-lived binary compatibility matters, right? That's why we want the standard ABI, but it's also why we need to recognize that vendors that have those customer requirements are going to keep their ABIs for a long time. I think what's really important, right? If you look at what Hui has done, initially he was resistant, and it was good that he was, because he was very thorough. And you can see in the refactoring he did for the ABI, some of those changes were not like they just happened because of the ABI. They were just putting some modularity in a place where it wasn't before, cleaning some code up. The actual ABI translation inside of MPitch is very, very small, and I would say there's no reason for MPitch to do a major rewrite to support the ABI. They've already accomplished it, and it has zero overhead. And I would say the same thing for OpenMPI. I mean, if you started tomorrow and you want to write a new MPI from scratch, of course, use only the standard ABI. But I don't think we need to lose a lot of sleep over what the implementations do in their code. I think the place where we need to push really hard on is the ecosystem, right? The thing that's going to make our lives bad is if we do the standard ABI and Debian decides to keep shipping OpenMPI with the OpenMPI ABI as the standard ABI. That's going to cause us problems, because that'll mean that we'll actually not realize any of the value of this. We need to get, and I don't think SPAC will be the problem, right? I think they have the wisdom to go do this aggressively, because they understand the HPC market better than the Linux distros do, right? But if we don't get this to the ABI to become the default in the packaging ecosystem, we will suffer. And I'm not going to lose any sleep about what vendors and ISVs do.
Can I add something, Jeff? Maybe the real advocacy for us should be that once implementations support the new API, at least we should advocate for making the implementations by default compile and link new software, new things that are compiled with MPICC to use the API from the very beginning, such that that is a way of basically forcing everyone to migrate to a new API, and you keep the old one for specialized use cases like producing something that is backward compatible with some older binaries. Maybe that is the right approach, because there is no reason in the next version of, I don't know, Debian, when they upgrade MPitch, to keep using the old one when the new ABI is available.
So I think if I remember correctly, the way the proposal is written, you cannot mix ABI and non-ABI execution in one binary, right?
We say you can't. It doesn't mean somebody can't creatively do it, but yeah, we're not going to claim that it works.
Okay, so it's not guaranteed, right? So an implementation. Sorry?
as it is, as the implementation is done today, as the proposal of today, you cannot do that. Because if you have MPI com-size, a symbol in the library, to which ABI will that function correspond? The only way to do it is if is in the ABI, we would mangle all the functions with some prefix or suffix that would allow to coexist. But that would be very messy for users, for end users, I think. So in the current proposal, you cannot mix the two ABIs. It would be possible, but you would have to do something like MPI com-size _ ABI. We need to add new functions with some name mangling to have two different versions of everything, of about maybe 600 functions. That would be the only way to do that. It is possible. I'm not sure if that is needed or if it is convenient for end users. Jeff, I don't know what you think.
So, we're not going to do it.
That potentially creates a problem, right? If distributions ship packages that are built against the ABI, and now I have my legacy application that is not yet built against the ABI. I'm building it not knowing that they have not ported it yet, which is easy, right? You just have to adapt your build system. But if you don't do that, then you're building against whatever legacy ABI there is. And now probably for EuroMPI it will work because the ABI constants will map to the same pointers that my legacy ABI is. But for MPICH that will not work because the numbers are different.
But you already face the same problem when every time you update your C compiler, you essentially need to recompile your applications.
Yeah.
No.
Also,
no.
Linux distributions could also ship the old ABI as an alternative version of the library that is used only for legacy applications. There is no problem about doing that. So you install a main package and then install the compatibility package that gives you an additional version with a different name, the usual names that we have today, like libmpi.so.12, and then it will support all binaries. That is a possibility that distributions provide.
In the short term, we have now 3 ABIs that distributions and everyone else has to support. Is that right?
Yes.
Okay.
Yeah, look, Joseph, you're right. For the short term, this is the XKCD meme because we have 2 ABAs now and we're going to have 3. But the whole point is that we all understand this topic well enough that hopefully we can go out and convince the world to stop using the other 2 unless necessary, and then we get where we want. But you're right. If people fight, then yeah, there will be 3. But, you know, my hope is people like Lisandro and Valentin, once they can actually depend on the ABI, they're going to stop bothering with the old nonsense because it makes their lives harder, and other people will do the same. And then there'll become enough pressure that people will just move, right?
Exactly.
But quick question, is the legacy stuff really an issue? Because once we change standard, particularly major version, the ABIs on the existing implementations don't hold anyway, right? So you cannot run an old binary against the new MPI 5, 6, 7 implementation. So they have to recompile anyway. Why not make the default that they have to compile against the new one?
You should talk to Ken. MPICH has been incredibly stable, although there have been very, very, very minor things that have. But yeah, I mean, you could talk. We discussed this at some point. I can't remember where, but Ken was saying that, you know, if they want to clean up even one single symbol in their ABI, they have to talk to the Linux packager people because then they have to do the SO version increment, right? And then that causes link failures in some cases. But, you know, the good news is, right, this is actually a great opportunity. Like, knowing that the ABI is going to change is a good time to get rid of a lot of technical debt. So I know MPICH, in some sense, is excited about being able to change ABI because, you know, they had a couple things there like, we are waiting for an ABI break opportunity to go clean some of this stuff up. And, you know, this will be one of those for everybody. Everybody will get to go clean up their garbage if they want.
Yeah, that would be my argument too. Now we have the chance. Let's just do it once and rip off the bandage now, right?
Absolutely.
Is there what is the reason for continuing to compile applications against the old legacy ABI? Why not?
None.
So applications will still ship it as an SO file, but when you compile an application, why not compile it by default against the new ABI?
That's what we all want.
That I want to advocate that.
What's going to happen, right? Because the header file is in a different directory, so you have to explicitly select that directory as your include path.
Well, look, we know that we've got MPI-CC wrapper scripts, and those scripts are either going to have a flag. Look, and I know Valentin, I hate them too, right? I don't use them myself, but a lot of people do, right? You can have MPI-CC default to the standard ABI, or you can not, but right, the MPI doesn't say this. Like, Joseph, I think what you're highlighting is a sociological problem. It's an important one, but at some level, I cannot solve this. If people are going to like hit their thumbs with hammers, their thumbs are going to hurt. And all I could do is say, please don't hit your thumb with a hammer. And if they won't stop, I'm just going to have to not feel bad for them. So people are just going to have to do the right thing. And yes, we're going to all have to work together, because MPitch will do the right thing at some point. Intel MPI won't do it on the same day. The ISVs, there's going to be this whole like problem where we're not in synchronization. And there's just going to be a couple of years where life is a little bit annoying, but we're going to get through it, just like we've gotten through, getting to the MPI 3.0 standard took like the better part of a decade, because from the time we ratified it, it took us almost 10 years before it worked. And it doesn't mean it wasn't worth doing. It just meant that, yeah, if you wanted to be weird like me and use RMA like crazy, you had to be really careful about it and ride through a whole lot of bugs. We're just going to have to do that. It's part of the growing process.
Yeah, maybe to add opportunities, we could also think not only of the application itself, but also applications use build systems. And for example, if you have the CMake build package for MPI, they just use a find MPI and then they enable it and everything is built out of the box for many applications. If we just attack at this point, more or less, like make the default in the build systems and the packages that support it, like they come out of the box with ABI if they detect that the MPI is capable of it. So maybe that could also help to distribute the stuff.
Definitely, yes.
Yeah. Any other comments here in the room or from the other online participants? So when Jeff, when you said we will have a couple of rough years to come to a good point and to have it easier, how long might this a couple of years be?
Well, it depends on the ecosystem pressure. Like, okay, so I was arguably the first heavy user of MPI RMA outside of the computer science MPI research community. And that was because ARMC MPI existed, Jim Dinan wrote it, and I took it over and I used it in NW Chem. And I dutifully reported all the bugs in MPI RMA implementations to MPitch, to Intel MPI, to Cray, and to OpenMPI for years. And some of them fixed them faster than others. The MPitch folks would fix the bugs almost instantly. Intel MPI did a pretty good job. I worked there at the time. Cray, they did a good job, but they had to wait in some cases for MPitch bug fixes to percolate out. OpenMPI, on the other hand, took a lot longer. Now, part of that was I was the only person asking them to fix RMA, right? OpenMPI is a project that is driven by community, right? Not the MPitch model of having vendors as the primary customers, right? And so if 10,000 people ask for send, receive, and broadcast to go faster or to support GPUs, and one guy is sitting there being annoying and complaining about every single RMA data types bug every 2 years, you know, what are they going to do in the limit of finite resources? I think the difference here, the contrast, the reason RMA, and I will say, by the way, OpenMPI 5 does a fantastic job with RMA and data types. It took them 10 years, and I had to be super, super annoying. But then when they got over it, they did a really good job. It just took a while to provide the incentive structure for it to happen. Okay, ABI, I think, is a much clearer scenario, right? We have MPI for Pi has some serious users. I don't know how important they are to, you know, in the grand scheme of all the things, right? But we also have tools, right? I know the tools folks, they're pretty quiet about this because they're really smart. They're really good at using MPI and they don't actually need this. But oh boy, is that going to make their jobs easier if we don't have to ship, you know, Scholastica for 1, 2, 3, 4, however many different things they ship, right? And all it takes is for somebody to say enough is enough. I'm not supporting non-standard ABIs in it anymore. And that person is going to have to be bold. But if their software matters, that's going to flip, right? It doesn't take much to just force people to convert over to make the default the way it is. So I don't think it'll take 10 years. I think it'll probably take, you know, I'll say 3 years, and you can tell me I'm wrong later. But 3 years where it's a little bit bumpy, but also, you know, it's only going to be bumpy some part of the world where you're depending on lots and lots of dependencies. This will make Lisandro's life easier in one day, because for the primary purpose of doing MPI for Pi with MPI with no other dependencies, when this is implemented properly in MPitch and OpenMPI, he can use it, right? It's only in a world where we have tools and libraries and vendor libraries and everybody's trying to glue it all together all at once that it's still rough because not everybody's in sync.
Yeah, if I can add
yeah, just go on.
I would like to add that I think Jeff is exaggerating a bit with the bumpy road thing. It depends for whom. For end users, for people that today are basically developing software for academic or research purposes and compiling software, is basically going to be extremely transparent. I'm very optimistic. From my particular own experience with MPI for Pi, the only thing, once MPitch got the implementation of the ABI and it was finished, the only thing that I had to do in MPI for Pi was basically to change if-def, simply to skip a bunch of backward compatibility stuff that I have for MPI, for MPitch and for OpenMPI, okay, to handle bugs and issues with those implementations. Basically, once with one line of code change, everything in MPI for Pi compiled straight away and run with no issue. So basically, my point is for users for people who use MPI regularly, building their own software, there is going to be practically no hiccups. Okay, and I remember that MPI for Pi uses 99.9% of the current MPI API. And there was no need to change a single line of the actual important code. Only some configuration stuff in header files to work around issues with particular implementations. That's all.
Yeah, sounds optimistic. But following up from Jeff's last comment, I have a question on both Lisandro and Valentin. So if we have the standardized ABI, do you need something else, or is this enough for you to provide your language bindings for Julia and Python? Or do you need something else from the MPI forum, from the MPI standard to come in to make it work actually for the other languages?
I think from our perspective, once we have the ABI, we will aggressively drop support for everything that doesn't support it, to provide part of the social pressure that Jeff was talking about, and have tooling like MPI Trampoline to make it still possible. But from the Julia side, I will gleefully delete several hundred lines of code, and it will probably then take us a little bit longer to get all our binary building for user libraries like LAMPs in order, but that should be relatively straightforward, and that's just on our side. So I think once we have an ABI, yeah, the code base will look less messy and has less corner cases to worry about.
Yeah, the primary additional change that we need, and we are already working on it, is to have context in all the callbacks, for instance, and that involves operations, reduction operations, and error handlers. So basically, we need that. We need to add context to all callbacks to not need to do tricks like trampolines, GCC trampolines. And the other maybe small piece, hold on, I have it in my head, and oh yeah, maybe if I could add is the possibility to attach attributes to other MPI handles, because right now attributes can be attached to communicators, data types, and windows, but not files, not operations, not requests. I would love to have a way to attach stuff, user stuff, to a request, such that, for instance, I could, when I create my own request and I need to, or not my own request, maybe a standard request, I would like to associate that request with a Python object that provides the memory buffers, such that it interacts well with the garbage collector. So those kind of additional small things would be really helpful for high-level languages that have a garbage collector and where you don't have predictability, and the memory management is more automatic than in C.
Yeah, that's actually a good point. Like memory management, we have a interesting application where we're currently seeing some stalls occurring every now and then. That happened because Julia garbage collection was running during this time step on this rank and running on that time step for this other rank, and then get pauses and communication mismatch. And so that's a bigger open question of how do we do this well? How do we, as I said, also like integration with task ABIs right now, if you do an MPI blocking operation, you block progress on all of the Julia tasks. And if you do a non-blocking operation, well, now somehow Julia needs to know that it needs to call back into MPI to make sure that you make progress. So those are bigger open questions, but
on the mic. Other questions here in the room? Any other topics you would like to touch here? Okay, we have one.
Yeah, so it seems like the Rust was mentioned earlier, but the person responsible for it maybe isn't on the call. But I was wondering if anyone on here does know about that, and particularly around Rust bindings with memory management, like Valentin said, that would seem to be an issue with Rust's memory semantics to me, but I don't know enough to comment more than that.
So yeah, so Lisandro Gonzalo and Jed Brown are both interested in Rust, and I've talked to Gonzalo, who works at NVIDIA, extensively. So to first order, Rust and Julia are in the same boat, and the reason is the problem that Rust wants to solve is the universal problem of not having to ship multiple binaries, and the second thing is that Rust, for obvious reasons, they don't want to deal with C source code. They don't want to deal with doing C compilation, right? Because they exist in part so that C isn't part of the universe, right? They want to do direct binary, call directly into the binary based on an ABI, the same way Julia does, unlike Lisandro, who carries around, the C glue. Right, so that's a big part of it for them. In terms of memory semantics, that is beyond ABI. It's a great topic, but it's unclear to me as a Rust amateur that you can actually resolve that. I don't know that the C API or the API is the issue. It's if you implement MPI in C using all the dangerous memory unsafe tricks that we do, is it really possible to be memory safe with a Rust wrapper around it? And I would say Howard Pritchard is probably not in the room there, but Howard has been looking at doing some things with implementing lower parts of the stack, you know, like MPI itself in Rust, using the Rust UCX wrapper. And that is potentially in, you know, if you're a real Rust, you know, hardcore purist and you want to see that sort of a thing happen, you know, a Rust API for MPI implemented in Rust is probably the path to solution. And then it's the CABI isn't, or MPI CABI isn't really critical, because you're doing more like what Lisandro is doing. You're implementing your own API defined by Rust. You can define Rust MPI using Rust semantics and define memory the way you want, and define sentinels and all these other weird things the way you want that makes sense in Rust. And if you implement those bindings in Rust on top of the low-level networking stack, then you could get as safe as you can get until you hit the networking layer.
Yeah, that seems reasonable. Like, to a first approximation, you can do just like a simple C wrapper around it once you get the ABI done, but that's not very idiomatic and it's not very nice to use. So it seems like, yeah, there's two separate issues here.
I would add to that we on the Julia side, we try to strive for two things. One of them is we want to give you full flexibility, and if you are well versed in the MPI standard, here all of the function exposed, no question asked, do whatever you want. But on the other hand, we have users who are like, well, I want more idiomatic Julia code, and so we provide Julia proper style wrappers that take Julia arrays and say, hey, by the way, we know the length of this data pointer, and we can automatically tell MPI that you don't need to worry about this, right? So Julia is not a language like Rust that said we want to, data safety is our priority, but because we have better information about our objects, because for GC purpose, we need to know how long a memory region is anyway, or we have view support, right? All of those like richer data structures, and we're not just handing around raw pointers all the time. That increases usability, but also safety to some extent.
Thank you.
Hello, I'm an end user Fortran programmer, and I'd like to submit a ticket to Jeff at the moment. I've had used the PGI compiler with OpenACC offloading and working with, I think pretty sure it was OpenMPI 2 years ago. And then NVIDIA bought them out, and we had that installed, and soon after I had that also working, but not anymore. For some reason, there is incompatibility between NVIDIA at the moment. So this is on the Guardian machine in Canberra in Australia, and offloading works perfectly fine. A matrix gets calculated perfectly fine, but then when scalar pack is called, which we get from typically Intel MKL, seg faults, and I've given up and waiting to get the latest version of G4chan going to see if we can solve that problem. So which which MPI should the NVIDIA compilers be using? And with the point that I do need access to scalar pack.
Well, okay. So the first order, I'm gonna take the easy approach and say I'm pretty sure the problem is actually an MKL scale pack. Cop out, obviously, but I will say, having reasoned about the problem in my head, it is probably an issue with the managed memory or the memory management in the OpenACC stack interacting badly with Intel MKL with MKL scale pack, right? It's just the way life is, because they're not compiling MKL scale pack with our compiler, obviously. But you send me an email. I'll put my email in chat, and we could go through the details. But the long-term solution here is if we ship scale a pack that's built correctly with our compiler support and OpenMPI support, you should be fine. But we're not doing this. And I will say at some level, this does illustrate a lot of the challenges of ABI and tool chain interoperability that we're trying to solve, but not this one. This is not an MPI ABI issue, sadly.